I've been working on programming the ancient microprocessor. This was a kit my dad's friend got in the early 1980s. I forget exactly when, but we got it all working, and we recently, my friend Cyrus and I, got it doing a bubble sort, which is the most basic sorting algorithm. So let me show you that. So reset. First of all, how do you program it? So you got to reset, and then now we've got memory protect on. We're resetting. So we're going to load, and now we can step through the program. And this is our address, and this is the memory, the data in the memory at that address. So I'm going to step through here. Now on my way through, I am going to stop at location 2B because I want to change the data in 2B. A, B. Actually, I want to change the data in 2C. So I want to go change the data in 2C to F7. I believe we've changed it once before. I can't see what's in there, and I can't go backwards, so I'm just going to assume that I need to change it to F7 and then in. So now C2 is equal to F7. Now I'm going to put on memory protect again so I don't erase the rest of the program and step through. Now here we are. That's the end of my program, is at 4.3 because it's 4.2, and then that takes up two things. So the last one's 4.3, which is 3E, and then my data comes afterwards. This is different because we programmed in different data in here. So if we look at it, we have 00, 02, 03, 05, 09, 33, 77, 77, F0, FA, FF, and then 60, which is fine because we only sort a list of length of 10, but there's still random stuff in the memory which hasn't gotten cleared out or just gobbledygook from whatever. So now if we reset this, turn off memory protect, and run it. Okay. It's going through the list. It's cycling through. We had a completely unsorted list because by changing that, what was it? It was F5, but we changed it to F7. That's subtract. We changed it from subtracting the memory location, subtracting D from the memory location, and we changed it from subtracting the memory location from D. So we switched which one we're subtracting from where. Excuse me. That makes it sort the list in the other direction. So I'm going to turn on memory protect now. I'm going to reset it. I go to load. Now I got to go to in and see if we sorted. This button gets a lot of abuse. So now we need to go to (4.3). Now this should be in descending order. The highest one should be first. So we got FA, F0, 77, 77, 33, 09, 05, 03, 02, 00, and now FF, but we only went to 00, so that's perfectly fine. So it did all 10 of them. I can change that in the program to sort a longer list if I wanted to, but 10 is good. So let me show you how this works. So here's the flowchart for for bubble sort in 1802 assembly. This would work for any different program, but this is the one I came up with, any different programming language. So this is what I used for the 1802 assembly though. So first we sort of initialize the main program.
And that's this part of the code right here. We set register X to, we set the X register as register 4. We load the location of the main program into register 3. We load the location of the delay subroutine into register E. And then we set Q. Setting Q marks the list as unsorted. So we need to do that right at the very beginning. And then we set the program counter to be register 3. So then the program jumps to the location specified by here by main, by that memory address. So next, we initialize the sorting algorithm here. That's this part of the code here. So TBS is to be sorted, and that gets loaded in to register 4. So register 4 contains the memory locations of TBS. Here, we're setting the length of the list that we want to sort right here, and we're putting that in register 5. Oh yeah, branch if not Q. So here we're checking to see, is the list sorted? Seems a little weird to do that first, but it works best for the way the rest of the program works. So we can just branch up to here when we're done with a loop, and we can go down through here, and it'll check to see is the list sorted. This could actually be up higher, and it would maybe make a little bit more sense, but whatever. So we're checking to see if the list is sorted. Now, the first thing we do actually is we mark the list, we reset Q. That marks the list as sorted. But we're not done yet, so we're going to go through and do the sorting algorithm. So next we decrement register 5. That was where we put in the length of our list. And we get the low bits of register 5. If there's 0, we branch back to the beginning. So that's advancing the list location and then checking to see if we're at the end of the list. That's these two instructions. And this set P thing, that just goes to a delay so you can watch the list get sorted in slow motion. So it doesn't go full out. And then we load D with memory location X, and we output that, and that increments X at the same time. So that is loading the first section of memory here. That gets loaded in. Next slide. Since outputting the data increments X, we can now X is pointed to memory location X plus 1. So now we've got D, this is now registered D, and then we've got X pointed to memory location X plus 1. So then we can subtract D from memory, so we can go D minus mem, or if we go the other direction, we sort the other direction, we go at mem minus D, and that'll make it sort the other direction. If it's branch if greater than or equal to the sort. So if this is greater than or equal to memory location X, it just advances to the list position, goes up to sort, and then goes through this loop. So if our items are sorted, just keeps going through the list, next item, next item, next item. But at some point, assuming we didn't start off with a completely sorted list, this is not going to branch here, so it's going to go down to the next instruction. So here I've got a couple of no-ops as just filler space in case I needed to add in another instruction here if I had something wrong in my loop, or if I wanted to change how this branch worked. I can branch if greater than equal. I could branch if less than, but then I also need a branch if 0 because there's no less than or equal. It's only branch if greater than or equal. So then we mark the list here. Setting Q marks the list as not sorted. So because we had to swap one of the items. This whole thing is swapping the two memory locations. We move them around, we load, we store, we swap them around. So I don't need to get into too much detail on how that works, but that swaps memory location X with memory location X plus 1, and it flags that a swap was made. Really, in the flowchart, these should be in opposite order, because first we're flagging that a swap was going to be made, and then we're swapping, but whatever. It's pretty close to being good. And then, so eventually, we'll go through this list, and eventually, well, first of all, if we go through the list and we reach the end of the list, then we go back here, we check to see, were any swaps made? Is the list sorted? If a swap was made, then we go back to here, we advance, we go through the whole list again, and we check it again. But eventually, it'll make it through the whole list and not swap any items. So then, when it reaches the end of the list, it comes over to here, initializes, checks to see if the list is sorted, and since no swaps were made, it is sorted, and then we go to the end. So, and when we reach the end, all we do is we set Q, we go to the delay, we reset Q, we go to the delay, and then we branch back to the beginning again, and what this does is just blinks Q.
So that's bubble sort working on the 1802 microprocessor ancient computer. The code is up on GitHub if anybody is really that interested in 1802 assembly. But one thing that we ran into here, should be able to see, it's talking about this in the flowchart. Branch if, has to be branch if greater than or equal. So you got to do branch GZ or branch, these are all the same, 3, You can't branch if less or minus, because that, well, you can do this, you can apply that with a branch if 0. You have to do 2 instructions versus the 1 for branch if greater or equal or greater. So that's the instruction we have to use. It's 3. You would think that you could switch the sort direction in the list by just switching the 3 to 3b, branch if less. But that doesn't work because it needs to be branch if less or equal, and there's no instruction that's branch if less or equal. So instead, we go up here and change the direction of our subtraction, whether subtracting memory from D, or subtracting D from memory, one or the other. So that'll switch the direction of the list. There's also some extra codes in here, some extra space. They're still in this version for editing, but I have some no-ops in there, some C4s, and what that does is it lets me have some free space in the program, because if you want to add a line to this program, well, first of all, you got to type everything afterwards that comes after that line, because you can just insert a line and shift everything down. That hadn't been invented yet, or if it had, it wasn't implemented in this thing. So you have to start all over, do everything after that. So that's no fun. And also, if you did that and moved it, you'd change all your addresses of stuff that came later. All the addresses would be off by however many lines you inserted. So instead, I added in some no-ops. It just does nothing and moves on, but that gives me free lines in the program to add stuff, or if I want to take out a line, because anyways, I can add in a no op again. And you get this lovely manual. Talk about user unfriendly. I just got this too. It's a Pi board. Fantastic little thing. The difference between these two is just phenomenal as far as ease of use. So anyways, that's the program. Bubble sort written in 1802 assembly. If I had a good way of inputting in programs into this, I'd write more stuff for it, because it is kind of fun writing to it. But I really need to get something like a Pi face or an Arduino or something to feed this a program, because as it is, it's just brutal typing in the program by hand. It's the keys don't work, and it's just really time consuming. So doing a longer program in here would just take forever. So that's on a list of future things, make a programmer for this thing. But I don't know if that's going to happen. Probably need to write a bootloader program, which would be short. You type that in and they just load programs. So first we hit reset and then load and start typing in the program. So it's E4 in. E4 shows up at memory location 00. Then F8 in. 1-8 in. A3 in. So that time I said A3 and it came out as 1-8 for some reason. So now I'm going to turn on memory protect and reset load in E4 F8, and then now F8 in 10. Now I need to go A3 in. Messed up again. Now it's 3-0, so I got to turn on memory protect again. Reset load in 1-8. Yeah, so now A3 in. A3 is correct now. So F8 in. 0 in. B3 in. So that came out as 8-3 instead of B3. So now we need to turn on memory protect again. Go to memory location 5, which is 1 before 6. Reset load 5. And then that was B3 in. B3 is correct. And so on. F8 in. 0 in. So finally got that all typed in. So let's see, memory protect on, reset load. So we've got E4, step through. As you can see, when I made a mistake, it took longer and longer to cycle back through, because you can't just go to a thing, you can't go backwards. So if I go past where I want to edit, I've got to do the whole loop again. So now, if we look at our list of numbers, starting at location 44, we've got 32, 25, 26, 77, 45, 50, 07, 67, 67, 76, 66, 45, 51, 10, 66, 68, and so on. And if I keep stepping through memory, you can see it's just kind of random gibberish from when the RAM chips reset. So now, if I reset this, turn off memory protect, and say run, did all that flashing, ran through our list, and now Q has stayed on. If you saw Q flashing, that meant Q was our sorted/unsorted list flag. So when Q is set, it means that the list is sorted, I believe. It should be flashing Q at the end. Maybe I got a typo in it. We'll see if our list is sorted. So I'm going to turn on memory protect and reset, load, and check our list. It should start at 44. So we've got 77, 76, 67, 67, 50, 45, 32, 26, 25, 07, and then we're out of the list now because it only does a small amount. Now we're back into the random gibberish in memory. So now if we go reset, load. Now if I want to change the direction of the sort, I have to change SM, I have to change F7 to something else. Let's see. So I got my book here. I forgot which one it is. So F7, SM, subtract memory. So we're subtracting D from memory. And if you do it the other way, if we if we subtract D memory from D, or if we subtract D from memory, which one, where is it? Yeah, SD, subtract D, subtracting D from memory, or if we subtract memory from D, that'll switch the direction of the list. So now I need to go to location 2B. So reset, load in, go to location 2B, because I'm changing location to C, and we're changing it from F7 to F5. So we go F5 in, and it didn't come out right. 5, 6. So we got to turn on memory protect, reset, load, go back to location 2B. Six, 4. So now we want F5. F5 in. It worked this time. So now I'm going to reset and run. That's all the flashing, it's running through the list. And now we are going to turn on memory protect. We're going to reset load and we check the list. Go to location 44. It might have been better to put the list at the beginning of the program, but you can't have everything. Can't think of everything. 44, so 07, 25, 26, 32, 45, 50, 76, 76, no, 67, 67, then 76, 77, and then now we're out of the list again. So that's bubble sort working on the 1802 microprocessor ancient computer.
I hope you liked this video. If you did, I'd hope you'd consider subscribing. I've got a virtually endless supply of projects I could make videos about. If there's something I can do better, or if there's a type of video you'd like to see more of, leave a comment down below.